and we're going to be showing you some techniques that we're using at Soil Secrets to make it easier for the grower to use these type of products. One of the techniques is to incorporate into the TerraPro a microbial consortium of a bunch of different species of beneficial bacteria. Those products are manufactured for us by Biodyne. Thank you very much, Biodyne. And then once again, Sterling Pacific, who is one of the companies that can make this product available to farmers, landscapers, mine reclamation companies, anywhere in the country. And let's see, also we're going to show some nanotechnology that can be incorporated into it, and that comes from AquaYield, a company up in Utah, doing some very, very exciting work. So let's begin. And again, keep your mute button on mute, and at the very end, I'll let you jump in and start asking questions. So the question might be posed, what is TerraPro, the carbon matrix, and what can we do with it? So I am the founder of Soil Secrets. My name is Michael Martin Melendrez. And the TerraPro product is something that I've been working on for a long, long time, trying to figure out how to use a biomimicry approach to repairing soils. But a little bit of history first about how we got from there to here. Back in 1980, I was involved in wellness, human wellness. That's my background. Occupational wellness, human physiology, and so I started a company called Corpora Fit Systems in 1980, which we took out into the world of corporations, and the idea was to teach their employees how to become healthy through a total wellness program, including nutrition. This really kind of got me started on the quest to work with soils, because one of the things that we discovered in working with nutrition on the wellness side was that the food that we were eating was in rapid decline in terms of the nutrient density, the level of vitamins and minerals in the food. So it became apparent to me that in order for me to be successful at what I was doing and helping people become well, that I needed to first address the environmental issues, including why is our food not as nutritious as it once was. There's plenty of research to document what I'm saying, that we've seen a dramatic fall off let's see here. There we go. Dramatic fall off. What are you trying to do? Oh, okay. A dramatic fall off in the level of vitamins and minerals in our food, in some cases as much as 30% in just 3 decades of time. That's not good. And so in 1985, I started growing trees as a side business, a tree farming business. These were trees for landscaping. And I wanted to use a biomimetic approach to growing these trees. In other words, we wanted the trees to have what they would have in nature, all the beneficial microbes, the fungi, the things that are associated with the roots of the tree, helping it survive in the wild. And so my theory was that a tree that was grown in the wild was considerably hardier than one that we grow in a landscape that we have addicted to using a fertilizer program. So I began working on developing biomimetic methods to grow these trees. In 1985 or 86, we purchased some land in Los Lunas, New Mexico, to develop an arboretum and also to live on the site. It was our home site. And this particular property had a problem. The problem was that the soils were a horribly saline and sodic alkaline clay. There are not many trees that like to grow in that kind of an environment. So Once again, going back to the biomimetic methods that I was implementing on the tree farm, I used these same methods to regenerate the soil on the Arboretum site. Today, that Arboretum site is one of the largest collections of trees in New Mexico for sure, and probably throughout the Southwest. And so there's many different kinds of trees there growing that should not be able to grow in a saline sodic alkaline clay because of our success in bioremediating those soils. In 1998, I decided to begin a research project to try to find the elusive humic acid molecule that has never been described. No scientist anywhere on the planet has ever found a humic acid molecule or a fulvic acid molecule and described it. And so, well, since there's lots of fertilizer companies selling that stuff to farmers, I thought it was kind of ridiculous that we didn't even know what it was. So how do we have any idea of whether or not it's really there or really going to be effective? This slide is showing you the Arboretum site at the beginning. The upper left-hand photo shows the salts and the white alkali on the surface of the site in 1986, and the image to the right, taken in 1998, shows a vast improvement. In fact, the three trees that Carrie and Amanda and Sam the dog are positioned by are redwood trees. The bottom picture shows those same redwood trees in 2005. So we've accomplished a lot in restoring the soils on that site. This slide shows you a close-up of the exact same spot 30 years apart. On the left is the dispersed clay. Because of the high sodium levels, the clay is dispersed and collapsed and is not a very healthy situation. And the image on the right shows that the soil is now deeply aggregated, rich in carbon. In fact, we've measured the carbon levels on the site and have calculated through extrapolation that there's about 360,000 pounds of carbon 1 foot deep per acre on this site. That's a lot of carbon. So this site is proof of the success of a carbon sequestration process that we've accomplished. In fact, watch this. This is actually a hole that is in the ground on the Arboretum site. Now remember, this was a heavy clay, high in salts, high in sodium, dispersed, and hard as a rock. The PSI on the site was at 300 when we first began. Now it's somewhere down around 25 to 50. Looking at the soil here, that is now very rich in carbon. This had been highly alkaline clay, a saline sodic alkaline clay. And after 30 years, it's now rich topsoil. I just pushed over this dead stump of a Dawn redwood that froze in 2011 when we went to 22 below zero, and left behind this hole. And it is really nice, rich, carbon-rich soil. Look at that. Isn't that great? So there's the proof that you can create a carbon sequestration process by getting back into the what we call the biogeochemical process, or the using biomimicry. We can get nature to sequester carbon back into the soil, and ultimately, in order to have healthy soil, we have to have carbon. That's what topsoil really is. So let's start off first with a little bit of science. This graph is showing you the levels of the electronegativity factor, or the cation exchange capacity, with different types of substances. At the very bottom, if you look at the bottom right, you can see loamy sands and sandy loams are at the very bottom of the scale. And above that, silt loams and clay loams are a little bit higher. And you can look over to the left and see what the potential cation exchange capacity is for those materials. And check out compost. Compost is going to be somewhere, roughly around 40 to 60 cation exchange capacity. Biochar is right around 14, pretty low. So by adding biochar to a soil that's already at 14 is not going to accomplish anything. Or if you have clay, clays can be up even as high as 30. And so if you're adding biochar to a clay of 30, you're wasting your time. It's not going to accomplish anything. So you have to understand what this cation exchange capacity is, and that the innate chemistry of the material, such as the sand, the silt, the clay particle, has a charge value, a negative charge value that gives it the ability to attract something with a positive charge value. So it gets a little bit more interesting than that when we get into the biomagnetic factor, which is charges that are coming from substances made by life, by biological life. This image is actually showing a biochar site in the mountains above Las Vegas, Nevada. That site's probably been there for many hundreds of years. And as you can see, it's not particularly rich in vegetation. The biochar is not really contributing a whole lot to that spot. Now, the biomagnetic factor. This image is showing you a aromatic ring. If you studied organic chemistry in college, you'll know what this is. This aromatic ring is actually a induced magnetic field. In other words, it's creating its own magnetic field within that ring. So if you have one ring, you have a certain potential of biomagnetism. If you have 1,000 rings, then it's even more. Now, when I first started looking for the humic acid molecule back in 1998, this is what was hypothesized by Dr. Stevenson back in 1982 as a humic acid molecule. However, Stevenson never actually found it, and nobody else has either. But this is what we were basing our theory on as to what a humic acid is supposed to be able to look like, and what functional groups are attached to it, and potentially what it should be able to do for us. This is what I actually found. Now, what we were doing is taking soil, exemplary soils that were rich in carbon, and doing a purification to separate the carbon matrix, or the recalcitrant carbon factor of the soil, separating it from the soil without harming it, without using strong chemistry like a base extraction chemical to extract it out of the soil. We did something different than that we had to actually create the method. And then from there, we were able to do what's called a molecular characterization study with the help of the National Nuclear Labs in New Mexico, Los Alamos and Sandy National Labs. And finally, we were able to put all the data together using artificial intelligence and mathematical formulas. We were able to put it all together and see this. So this is what the molecule actually looks like. And if you look carefully at that, you can see those aromatic rings within the molecule. And there's a bunch of them. This is a massive molecule. It's about 5 Daltons in size. That's huge. Now, if I take a piece of that molecule out, I can actually show you the induced magnetic field creating a charge that is very, very significant to how this stuff works. So if you look carefully, you'll be able to see a spark at the same time on either end of this molecule, over here and over here. And hope you can see that cursor. And you can see the aromatic rings. These are functional groups, these orb-like structures. They're functional groups that are attached to this fragment. So this fragment is generating a massive induced magnetic field, which is charging these functional groups, giving them the ability to attract other things into the molecule, which I'll show you later on. And so it's important to understand that in chemistry, a functional group is a group of atoms that are attached to a molecule that are responsible for the chemical reaction of the molecule. Now, Going back to that cation exchange capacity and the electrical negativity factor of clay versus sand versus biochar versus anything else, um, if you were to take a water bottle and rub it vigorously on a stack of paper towels and then run a stream of water, like you can see in this image, hold that water bottle close to that stream of water, you'll see the water bend and go towards the bottle. So again, the electrical charge in the water bottle is actually pulling the water towards the bottle. And this has to do with the fact that the water molecule is a polar molecule, meaning it has both a positive and a negative on the same molecule. They're in a direct line of sight of each other. And so the positive side of the molecule is going to be attracted to that negative charge of the water bottle, turning and facing the water bottle and then be pulled towards it. So the same thing happens in soils. If you have a sandy soil with a poor negative charge, it's not going to be very good at attracting water because of the weakness of that magnetic charge. Versus clay, which has a stronger magnetic charge, higher CEC, I'm sorry, higher cation exchange capacity. I hate abbreviations. Then it's able to pull more water into the soil. So if you look at the product that we have, which is a replica or a bioidentical molecular substance to what we found in soil when we did our research, it has a phenomenally high charge potential or dipole moment. And because of that, it's able to function as a humectant. A humectant is something that can actually, because of its charge value, can pull water into itself and hold that water. So, for example, they put humectants into ice cream and cosmetics and other things that they need to keep wet, that they don't want drying out. So, the carbon matrix of TerraPro is a very powerful humectant. And this slide illustrates how it's able to pull water molecules into the carbon matrix and therefore also help us manage moisture in the soil. So here's some evidence to prove my point. This is a vineyard in Baja, Mexico, about an hour drive south of Ensenada. It's out in the desert. It's very hot, very dry. Never rains in the summer there unless there's a hurricane coming through, and that's rare. And when they put down the TerraPro on the road to the right, they put down 1,000 pounds per mile of row, that you can see an obvious difference in the performance of the vines because they're getting more water and they're also getting more nutrition out of the soil versus the control row, which is to your left, which didn't get anything. The grower actually provided us some data at the end of the first growing season, showing that their tonnage increase in grapes on the treated rows went up by 55.9%. The water consumption or water demand on those treated vines was also dramatically lower than the non-treated vines. Looking at close up at what did the grapes actually look like on the vines, and these photographs were provided to me by the grower. I didn't go out there and cherry pick and take the best photos possible. The farmer actually sent these to me. So the vines that were treated with a TerraPro, you can see have a very lush production of grapes, very, very healthy looking, and the ones not treated to the left, not so healthy looking. So what else can we do at TerraPro to make it a great product? And this is where Biodyne comes in. Biodyne makes a product called 401 that they let us label as a Soil Secrets product called Consortium Biopack. We can actually spray this liquid mixture of bacteria, beneficial microbes. We can spray it onto the matrix while it's still in the production phase in our ribbon mill. And that way it already contains it, and the farmer doesn't have to do two different applications. They can do just one application and get two different benefits at the same time. So these microbes provide a whole host of benefits from including bacteria that are capable of fixing nitrogen in the soil, um, increasing the level of proteins, amino acids, um, everything that's good that has to happen in the soil coming from bacteria. Now, the other thing that we can do, and this is a technology that comes to us by way of aqua yield, where if we have a specific problem, like let's say we're growing pecan trees in the desert of southern New Mexico or southern Arizona, where the soils are highly alkaline. And because they're alkaline, phosphorus and zinc are not easily available to the trees. Well, if we can load phosphorus or zinc into a little tiny particle called a nanoparticle, and then we can put that nanoparticle into the carbon matrix and bridge that gap, bridge that deficiency. So the farmer has the opportunity to also just spray that nanoparticle right onto the foliage of the trees, and it would work just wonderful. But this is another way that we could do it. So in addition to the microbes being in there, now we can put the nanoparticles in there. How about minerals? Well, if you're in acid soils in the eastern part of the country, you're probably going to have a mineral deficiency because the reason why the soils are acid is because they're low in minerals. Through the eons of time and high rainfall, the minerals have been leached out of the soil. And the lower the mineral levels go, specifically your cations, your alkaline minerals, the more acidic your soil becomes. So if, you can certainly grow a crop in an acid soil, but what you're growing is a crop of empty calories, one lacking the essential minerals and vitamins that we need for human nutrition. And so this is where the idea of remineralizing the soil comes into play. And so what we're able to do is take a broad spectrum mineral product and spray it onto the carbon matrix along with the bacteria and the nanoparticles, spray it onto the carbon matrix. Because of the positive and negative charge values, the functional groups that are part of that carbon matrix, they're going to chelate them and hold them in such a way that they'll become easily available to the crop that you're applying this onto. So here's some evidence. Pecan trees in southeastern New Mexico, I'm sorry, southeastern Arizona, right on the New Mexico border. And the leaves on the left, you can see we have some problems, some deficiency problems. And leaves on the right, same field, same crop, but the ones on the right were treated with the TerraPro, ones on the left were not. And you can see that it improved the situation. Here's some more evidence. The photo on the left, if you look at the larger trees, those were treated with the TerraPro. And then if you go to the right in the same image, you can see some smaller trees. All right, they were planted at the same time. The trees came from the same source. Everything is the same except the trees on the left were treated with TerraPro. The ones on the right were not. The other image to the right gives you a closer view of those trees that were not given the benefit of TerraPro. Now, here's the same field showing how the grower applied the TerraPro. The image on the left, they basically just used a spreader that could direct the spray of the granular TerraPro right into the row of where the trees are planted. And the image on the left, where this fellow is bending over and pointing to a strip, that's kind of how the vineyard did it in Mexico. This happens to be a pistachio farm in California, where they dribbled the TerraPro down right beneath the drip irrigation line that waters those trees. This is what we call a precision application. And again, the amount of TerraPro that is used when you do a precision application is much lower than if you just spread it over the entire field. Check that out. This is actually still in Baja, Mexico. Same farmer that's growing those wine grapes had a peach tree that was failing on him, full of borers, and he treated it with a TerraPro, and a year later took the photograph showing how much the tree had improved. Now I'm always doing R&D, proof of concept studies at my facility. I had the benefit of owning a nursery, and so this gives me the opportunity to use a lot of plants. And so what I did here is I planted um, corn into 500 5-gallon containers. Half of them were given TerraPro, and the other half were not. Now they were put into the rows in alternating. So you had 2 rows without TerraPro, 2 rows with, 2 without, 2 with, 2 without, down the entire irrigation line. And what do we see? Now remember, the soil's identical, the fertilizer's identical, the irrigation is a micro spray that's being sprayed over the top, so that's identical. The only difference is one has the benefit of the biomagnetic energy of the TerraPro and the others don't. And you can see a very obvious difference in the performance of the plants. We've done this with hemp, and we've done this with cannabis in our lab. And in this photograph, what we did is we actually took some used soil that was already spent by a licensed cannabis grower in New Mexico, and we added TerraPro to it. And then we bought some brand new soil, the favorite brand of the cannabis growers in the country. I'm not going to tell you the name of the product, but it's the product that's most commonly used in the United States by cannabis growers. And brand new soil. And the brand new soil had, according to its label, crab shells, bat guano, worm castings, all kinds of stuff listed, implying that it has a nutrient charge already in it. And so the used soil that came from the cannabis grower was spent. They had already grown a crop in it, and they were throwing it away. So they gave us that soil. We actually collected about 11,000 pounds of soil from them and played with it. And so when we put TerraPro into the spent soil, not the new soil, this is what we got. Unbelievable. You know, we were able to demonstrate that you can repurpose an old, wiped out, used up soil by just adding the TerraPro to it. Made all the difference in the world. So just a quick summary of the benefits that TerraPro can give you. It can cause soil particle aggregation. That's what I was showing you at my Arboretum site. That basically cause the clay particles to come together into micro aggregates. This improves the ability of water and oxygen to penetrate the soil, improving porosity. You can measure this with a penetrometer, which we have done, and see a dramatic improvement in how porous a soil becomes by using TerraPro. So the aggregation helps with the movement of water and oxygen into the deeper profile of the soil. And I can't emphasize enough how important that is, that everything that's good that has to happen in that root zone of your crop is contingent upon oxygen and water. We see pecan growers in New Mexico ripping up their fields with backhoes, trying to loosen up the soil because the soils have collapsed from all the salts that they have fertilized with or irrigated with. And the soils have collapsed, become really hard, water and oxygen won't penetrate. And the answer that the universities give them is to go in there with backhoes and dig trenches up and down the aisles of these pecan trees, tearing up the root system in order to get the soil softened up enough to get water down there. Horribly expensive effort. Not so sure how well it works, but I know for sure that I can put TerraPro down at a much lower cost to the farmer and get a better benefit than what they're doing to those machines. The humectant benefit, remember I showed you the molecule pulling water into it. That's the other magnificent benefit of TerraPro, and that it can help us reduce how much water we actually need to irrigate with. And with water becoming more and more of an issue, particularly anywhere in the western half of the United States, I think this is going to be a very important point to emphasize. So it helps to get the nutrients in the soil, the minerals in the soil available, because it actually contributes a solutioning process to unlock these minerals so that a plant can uptake them. And if the mineral is not soluble in water, the plant can't drink it. It has to be solubilized into a water solution in order for a plant to drink it. Well, we know that the carbon matrix of TerraPro will accomplish that. We also know that it'll reduce salt and sodium in soils. That's what I was able to do on my arboretum site. That was a horribly toxic saline, sodic, alkaline clay. And now there's a magnificent forest of trees from all over the world growing on that site. And we can use the TerraPro as a carrier to deliver probiotics, beneficial microbes, as well as minerals, adding minerals to it. There's all kinds of things that we can do. We can be real creative with this. There you go. So thank you very much for joining us on this webinar, and let's see if we can answer a few questions. Why don't you all unmute and
then I should ask you.
also, okay, go ahead.
Okay, Mike, I got several questions. Because of its extreme ability to hold nutrients, if I apply nutrient to your TerraPro, what percentage of those nutrients will be released by it? How do you apply it to existing orchards who have really poor soils? What's the cost per acre to do so?
Are you talking about the minerals that we're adding to the TerraPro?
Yeah, if you add minerals to the TerraPro, if you add 100 pounds, what percentage of those will be released to the plant, and what percentage will be bound up?
Well, once they're chelated into the matrix, the 100% of them are available to a crop.
Okay.
And so they're not going to be locked up. They're permanently available to the crop. And I might add that the molecule of the TerraPro, the carbon matrix, has a very long chemical life. In fact, we did studies at the national labs to calculate what the chemical half-life is of this stuff. And let me tell you, you will never outlive. If you live to 1,000, this stuff is still going to be actively involved in your soil. So if you put 1 pound down or 2,000 pounds down today, it'll still be there 100 years from now.
So that leads to another question. How often is it applied?
If you can only afford to apply a small amount, then you're probably going to need to apply it every year and build it up. So it just depends on what your budget is. If you can afford to put down a whole ton of the material per acre, if you can afford to do that all at once, then good for you. You must be doing pretty well financially. But it's going to work tremendously for you. In the case of the vineyard, they put down 1,000 pounds per mile, or the pistachio farms, they put 1,000 pounds down per mile, and that is equal to about 600 pounds per acre. And they got a magnificent benefit from that.
Okay, if I have an existing orchard, a pecan orchard, 20 years old on some really poor soils, how would you apply it? They're micro sprinkled.
I would just cyclone spread it out and just spread it over the entire root zone of the trees. And I try to get down at least 1,000 pounds.
Okay, so I could broadcast on each side of the tree about a 3-foot band.
That's right. And it does not need to be incorporated into the soil. It will impact the porosity of the soil going down 3 feet deep in the first year that it's there.
Oh, that's awesome.
Yeah, on a pistachio farm, on the picture that I showed of the guy pointing to that strip of the carbon on the ground, We measured the PSI of that site. It was at 300 PSI
Mhm.
before we put that TerraPro down. Before the end of the first growing season, we could walk anywhere in that field with a penetrometer, shove it into the ground, and be below 75 PSI. Now,
Great.
we all know that, well, not all of us know this, but it should be known that microbes and roots don't do very well in the soil with a PSI above 150.
Yeah.
So if we can get it down to 75, we're going to see progress.
Yeah. Ohio State said if you have PSI of 300, there's no way roots will ever penetrate it.
That's right. And that's exactly what we see with trees. And so, even though we walked 15 feet away from where that carbon strip was laid down, 15 feet away, the PSI was still down that low.
How do you explain that?
I can't.
Uh,
I don't know anybody who can't explain that.
If I'm putting 1,000 pounds per acre down underneath some trees on a banded, stripped band, how long till you start seeing results? Months?
Oh, yeah, months. Right. Yeah, we took visual images with satellite, well, not satellite, but drones and infrared vegetation analysis, and we could see in the first summer on these pistachio fields and with cornfields, we could see a change in the performance of the vegetation, the chlorophyll density, biomass production, temperature, all kinds of good things happening.
Is the TerraPro organically certified?
It is approved for use on organic certified crops on organic certified farms.
If I've got an organic vegetable grower and he puts compost down every year, could he put TerraPro with the compost that first year, then eliminate the compost in succeeding years?
Yeah, absolutely. I have a lot of farmers who used to use a lot of compost and now use just TerraPro. And but I also have compost companies that incorporate it into their windrows, and it really does a magnificent job of making a better compost.
Yeah, I deal with a couple compost makers, and it's a question I had.
Yeah, try to have them do some experiments doing that. In New Mexico, we have a lot of big dairies in our state, and they try to make compost from dairy manure. You end up with a compost that looks beautiful, but it's really rich in salts and has an extremely high pH. When we add TerraPro into the manure before they start composting it, the pH of the finished compost is about 10 times lower.
Yeah, the compost I'm looking at has a pH of 9.8.
Yeah, that's what we run into the dairy manure compost, about 9.5, and but when TerraPro is used in it, depending on how much TerraPro is used, we can get it down into the 7s.
When you put it, so you want to put it in when you first start composting. You don't want to add it in the last turn.
Right, you want to put it at the beginning.
Okay.
At the beginning, yeah.
All right. Hey, sorry for monopolizing the questions.
No, that's good. Those are very good questions, and we all can benefit from it. Anybody else out there?
Michael?
Yes.
I'm Larry Musser, PRZ Consulting. I work with the products that come from Sterling, and which they use your products. I'm a turf consultant. I've done consulting work on sports fields all over the United States for 30 years. I do seminars on sports field maintenance. I see all kinds of soils all over the country. I know what you're saying in the East. I see with the higher the rainfall, the lower the nutrient levels in the soil. I also noticed in the Northeast part of the country, where in the past we've had acid rain from the smokestacks. The pH is 5.5 sometimes, and it kills everything practically. The other thing is what excites me about what you're telling me today. I work high wear sports fields is my specialty, and compaction is a major issue when you have moisture levels in the soil, and they play heavy sports on them. We get compaction well over 200 sometimes, and trying to keep grass growing under those conditions very difficult. So I'm very interested in seeing what this would look like. Now, again, I don't know how this is going to compare application rate when you consider how many plants per square foot there are in turf, heavy turf, compared to windrows of crops. I don't know what amounts we'll be looking at as far as, most of these fields are like 100,000 square feet. We might have 10 acres of them, but we're, each field maybe 80 to 100,000 square feet. So trying to calculate how much product it would take. And is this a granule product or a liquid product or both?
It's a granule product, and I've used this product on turf for a long time. That's probably the very first thing we ever used it on, other than my trees in my production nursery. And I have built sports fields years ago when I owned a landscape construction company. One of the things that we specialized in was the building of sports fields. And so we use this product. And in New Mexico, one of the problems that we have is the highly alkaline soils become concreted because of the high calcium levels, both in the water and in the soil. The soil particles will concrete together and form a substance that we call caliche. It's like a sidewalk. And so when we put the TerraPro into the soil while building the sports field, it eliminates the concretion of the soil, keeping it very porous so that water and oxygen and roots can move through that soil. So it works quite well. Depending on how bad the soils are, in the case of one site that we built, and I can send you photographs to demonstrate what we were dealing with. The caliche was about 3 feet deep. You could not drive a rebar into it with a sledgehammer. That's what the school district expected us to be able to grow grass on. And the specifications, the construction specifications, did not give us the opportunity to bring in fill dirt. We had to grow it on the caliche. And so we did. And that was about 15 or maybe 18 years ago. And that site today is still a very healthy sports field. Now, we had to use about 10,000 pounds of it per acre to overwhelm that caliche. But that's a pretty nasty situation. That's very unusual. Normally, I would say about 2,000 pounds per acre is plenty. That'll work.
How deep did you incorporate that if you've got heavy clay like that when you're building a brand new one?
Basically, once we have the field to grade and it's ready to receive either the sod or seed, we top dress the whole area with the TerraPro and kind of scratch it in. So maybe a ½ inch.
Reason I ask that because I do a lot of work on brand new fields, and I basically write amendments to incorporate 8 inches deep on high wear fields. And again, we use a lot of compost,
right,
and whatever nutrients are lacking to keep those ratios of calcium to magnesium and so forth. I just wondered, you're talking about a small amount then for that much area.
Yeah.
As far as if you're just spreading it, that's amazing.
Right. Yeah, it's very cost effective. Remember, it's an electromagnetic field that is actually causing the soil to change meters away from where that particle is sitting. That particle does not have to come into contact with all the soil in order for it to work.
Amazing. Thank you.
You're welcome. Anybody else?
Michael, this is Dominic.
Hey, Dominic, how you doing?
Good. They're calling me Scooter here on the screen. So a couple of questions. Being an old timer with you, I don't hear anything about essential amino acids anymore. And then the other question is, how does this the carbon matrix work with just seed, not a plant? And how could it be applied, and how does it work with it? And then the third question is the relationship to the mycorrhiza. I don't hear anything about mycorrhiza anymore.
Well, this is a TerraPro webinar,
Yes.
Dominic. That's why we didn't talk about those other things.
Okay.
But the mycorrhiza is a very important part of any vegetation. 97% of all plants on the earth are mycorrhizal obligate, which means that they cannot live their full life expectancy healthy without mycorrhiza being part of their root system. And so when we're looking at urban landscaping, a sports field, for example, almost without exception, you will not find mycorrhiza in that environment. And there's field tests that can be done now that prove that point. So in agriculture, where the heavy use of phosphorus fertilizers has been traditionally used, that tends to chase the mycorrhizal relationship off of the plant, and the plant no longer will cooperate with the mycorrhiza, so the mycorrhiza die out. So Soil Secrets does provide mycorrhiza. We have an exceptionally good product, and we can even, in the case of that building of a sports field, we can actually coat the mycorrhiza onto the carbon matrix. The magnetic charge of the carbon matrix will actually hold the spores, and then you could spread it on the ground as you're before you're ready to apply the turf or drill the seed, and that would provide an adequate way of inoculating that site with the mycorrhiza, the same as we're doing with the bacteria. As far as amino acids go, amino acids are the building blocks of all life. So in order for us to have a healthy soil ecosystem, the terrestrial biosphere of the soil needs a source of amino acids. And the nitrogen fixing bacteria, the other bacteria that are going to be expanding their population in the soil because we added them and we gave them what they need, their bodies all contain a source of amino acids. They contain protein. Mycorrhiza, about 60% of the tissues of mycorrhiza contain protein. And so that contributes a lot to the building blocks of all life. Another thing that we're going to be developing here very soon is a mineral-rich algae, where we have intentionally fed algae these same minerals that we can spray onto the TerraPro. But in this case, the algae population will have a very, very rich concentration of protein that contain all of the amino acids, including the essential amino acids. So this could serve two purposes. One, it could be a food for a nutraceutical, or it could be a food for the soil. And so that's one thing that Soil Secrets is working on right now.
So we have to request these different materials to be added to the
Yeah,
Soil Secrets if and when we want them?
that's correct. Yeah.
Okay.
The TerraPro product, the agriculture grade TerraPro product, or what Sterling uses the name TerraPro Ag. When Sterling is going to be offering it, they're going to be having us include the minerals, the nanotechnology, and the bacteria will automatically be included into it.
Okay.
Yeah.
What'll that product be called?
TerraPro Ag.
Thank you.
Yeah. Anybody else?
What's going to happen with tillage in the, where I do a lot of tillage in my potato rotation?
Well, the tillage is not going to hurt the TerraPro. The TerraPro will continue to benefit your soil regardless of whether you're doing tillage or not. The only concern might be the effect that the tillage has on the beneficial microbes and the mycorrhiza if you're trying to get a mycorrhiza established in your crop. Tillage is pretty rough on them. So, but fortunately, those are very affordable to repeat, and so it's not an expensive process to re-inoculate with the microbes or the mycorrhiza, and that'll keep you on the journey to better soil health.
We didn't talk about the seed. How TerraPro would work with seed.
Well, I didn't include those images. I actually did include them, and then I took them out because I didn't want this to be too long. But I have lots and lots and lots of images of where we put TerraPro into hundreds and hundreds of pots, 5-gallon and 2-gallon size pots, and then put seed in there. And you can clearly see that the pots that have the TerraPro have much faster germination and more complete germination.
Okay.
So it does benefit that.
Thank you.
And any one of you guys send me an email. I'll gladly send you the photographs of what I'm talking about.
Michael, can you treat seed before you put it out with this in any way?
Not with the TerraPro. You can treat the seed with the mycorrhiza before you put it out. In fact, that's actually the preferred way to do it, is to dust the mycorrhiza onto the seed. But the TerraPro is a big granule, and that just won't work.
Thank you.
Okay. Anybody else? These are all good questions.
Yeah,
Steve?
Michael, I've got one quick question. This is Kyle Haggerty.
Hi, Kyle.
I don't know if I asked you this in the past or not, but how about in regards to applying this on frozen ground or snow covered? I'm just thinking of Colorado and maybe the High Plains region.
Yeah, we've done that, and it works quite well. The freezing and the thawing that the soil goes through during the winter seems to actually help it, and it helps to kind of get it worked into that top quarter inch or half inch of the soil. So definitely that does work. I'm not so sure how it would be, how the freezing and thawing would impact the consortium of microbes that we could be putting on there. Jerry probably over at Biodyne could answer that question better than I can.
Okay.
But if you're putting it down on frozen ground and dropping down to 30 below zero, the bacteria may not be real happy about that.
Okay. Thank you. I just had to ask.
All right, good question.
Michael, Tim.
Hello.
When you're doing this in restoration areas after a forest fire, how can we utilize this in relationship to that market? And can this stop the forest fires from happening again because the pathogens and everything is gone, considering we have healthy plants and healthy trees?
Well, I can't elaborate too much on that kind of a question because research really hasn't been done to address that. We have applied TerraPro on a forest fire site to see if it would eliminate the hydrophobicity factor faster. Because one of the problems you have with forest fires is that as the fire cools down and the fumes settle down into the soil, they deposit hydrocarbons in the soil that are waterproof. They're non-polar chemicals like oil. And so now when it rains, the rain won't penetrate and wet the soil. Instead, it runs off and you have floods downstream and big messes. So if we can break that hydrophobicity faster, then it's going to benefit the long-term health of the future forest on that site. But now, since TerraPro is a humectant and can improve the moisture management of soil,
it's 11 hours
dramatically. By applying it onto a site of trees that haven't been burned up already, it could give a competitive edge to those trees where they have more moisture available to them and they stay hydrated better, and therefore their kindling temperature is not an issue in terms of how quickly they'll catch on fire. So,
thank you.
Yeah.
Michael, can you hear me?
I sure can.
This is Kenneth Wheeler. Thank you for the information. I didn't catch all of it. I had another meeting, but I'm in Florida. And so if you covered our fruit trees advantage, why I missed it.
Well, I didn't specifically cover fruit trees. I talked a little bit about pecan trees and pistachio trees. And I showed one image of a peach tree that was dying. That was treated with a TerraPro and it revived it. We really haven't had that much opportunity to use TerraPro in orchard management. So I'm very confident that it's going to work, because whenever you improve the health of the soil, you stand a better chance of improving the health of the crop. Only a healthy soil can grow a healthy crop. So, and that's what we do. We get ourselves on the journey to better soil health.
We just have, of course, large orchards, and of course, we have other things besides oranges, whether it be grapefruit or whatever it may be in the type of fruits that we're talking about here. So I just thought I'd inquire and see if you'd had any experience there, or maybe they don't need it down here. I don't know. I'm not an expert in that.
Yeah, I couldn't answer that question since I haven't had the opportunity to work in that arena. I would sure
Okay.
love to have that opportunity. It'd be a very interesting thing to work on.
Well, I do have some connections there, so we'll probably be in touch with you.
Thank you.
All right, thank you.
Hello, Michael. This is Lynn and Carolyn up in Placitas. And I'm a chair of a soil and conservation district and soil and water. And we've been doing some projects out in really degraded rangeland that has been overgrazed for centuries. And we're not having much luck, doing permaculture type methods and sponge pockets and all that kind of thing. So do you think this would work, or would it be economical to try to restore these rangelands? They're down near I-25, they're not way up on the mountain.
Mm-hmm.
And I have another question too after this.
Yeah. Well, I think we've actually have applied TerraPro on rangeland between Albuquerque and Santa Fe back in 1996, and that particular product was very crude compared to what I'm able to make now. That was before we did the molecular research with the national labs. So once we did that molecular research, we knew what corrections we had to make in the product. So yes, it will have that benefit. Whether it's affordable to do it would have to be, again, relying on a very precision application. In other words, you wouldn't try to cover the whole ground with it. You would try to do it maybe in strips, and where you're listing it in strips so that you can get vegetation established on those strips, and then let it grow from there. Because this is a process of what we call pedogenesis. Pedogenesis, the word pedo is a Greek word meaning soil, and genesis, of course, creation. So what we're doing is we're stimulating or priming the pedogenesis process wherever that granule falls. And so when we put the microbes into the equation, the mycorrhiza into the equation, the seed, etc., then you're going to begin the healing process of that soil. You have to have a plant. The plant is going to provide the photosynthesis factor. Mm-hmm. And so during photosynthesis, that plant is going to manufacture amino acids and sugars, which are then carried down into the soil, which are fed to the microbes. Now, we might have to add the microbes because they might be missing from this equation, and it's cheap enough to do that. I mean, to put bacteria down per acre is about $16 an acre to do that. And so that's not very expensive. So but we have to feed these guys. They need to be fed. And how are they going to be fed? Well, they're going to be fed from the sugars and the amino acids that plant is producing. So we got to have a plant involved. And by the way, Kyle, going back to your situation up there in Colorado, where it's freezing cold in the wintertime, very difficult to keep a crop growing in the middle of the winter there, right? When it's 30 below zero, who's going to be growing? Not much. And so the problem with the microbes is that they need to be eating, and the mycorrhiza have to have a living plant. So if you plant an annual plant like corn or cheatgrass or lovegrass or some kind of a grass that's only an annual, once that plant dies, it's completed its life cycle at the end of the summer, and it dies, the mycorrhiza that was depending on that plant also dies. Mm-hmm. It has to have a plant to feed off of. So when you're working on rangeland restoration, you gotta make sure we're dealing with perennial bunch grasses that are going to stay alive all winter long and continue to feed the mycorrhiza.
Okay.
Okay.
And my other question is, we have a little sort of farm up here in Placitas, and we have soil that's based on the limestone, and our water is from springs that go through limestone. And so as a result, we have concreted soil, and it's very difficult. But
Yeah.
I was just wondering, can you reveal prices, and how much would a 0.6 cubic foot bag cost?
Well, you can buy TerraPro retail down at my retail nursery in Los Lunas, the Trees That Please nursery, and it's sold in a 0.6 cubic foot bag. It's not quite the same product that I've been talking about here, but it's still been enhanced with microbes, including the mycorrhiza. And I think, and I don't work the retail side of the business anymore. My daughter Amanda and my lady friend Anna do that for me, along with the nursery staff. And I'm going to guess that the retail price is probably around $85 a bag. If you're doing anything bigger than a couple thousand square feet, then you probably need to talk to Jim over at Sterling and get a bulk bag price. So he can get it to you in a 1,000-pound bag or a 2,000-pound bag, and that'd be a lot cheaper per pound than buying the retail bag.
Thank you.
Thanks.
You're welcome. Anybody else out there? I see Kim and Joseph in Arizona are eavesdropping in on us.
Eavesdropping, yeah.
Well, I just say it's been an honor to work with you, Michael. I was calculating the years. I think it's about 18 years now.
Yeah, about 18 years. Yeah.
And so,
Kim and Joseph moved out by Snowflake, Arizona, and they have been offering our products as distributors for us out in Arizona for almost that entire 18 years.
yeah. So I just encourage people. We do have a seedling program. There was a question about using it with seeds, and we have a solar greenhouses, and we use them on our solar greenhouses. We raise about 40 to 60,000 baby seedlings a year, and we definitely see very good results using the product on that. We have farms here, and we've watched our soil change around, and Michael has pictures of those. It's been pretty phenomenal. We do have fruit trees. We have a new orchard. Someone asked about orchard questions, and we've had phenomenal results on a new orchard that we planted in a shade house. And they're just in their second year, so they're like a year and a half old, and they're already 12 feet tall and hitting the tops of the ceilings, and have been pruned back to about 10 feet. We want to keep them about 10 feet. But it's been an honor to see it, and it's always changing and growing and learning what gets better and better all the time. So
one of the clients that Kim and Joseph have worked with is the Apaches on the White Mountain reservation.
Right, White River, yeah.
White River.
And the Hopis.
And the Hopis.
Yeah.
I got a photograph, or a couple of photographs that were sent to me on a new site that they were cultivating. And it was remarkable as to the change in the soil. You could see a visual difference in the soil inches away from what was treated versus what was not treated. The color of the soil, the carbon content in the soil had changed dramatically. It was amazing. It was a wonderful photograph. I was actually gonna include that photograph in this presentation, but that was pretty fast.
Yeah, I would say that we see the results. There was a question about when do you see the results, how quickly? And I would say we see differences in the plants themselves right away, very soon. from germination rates and how quickly things germinate and how well they do, to plants that we might put nectar ambrosia on, and we see the results right away in lettuce within a week. The soil changes we see them a little bit slower. Those are more like in months or in the years as one changes, but you see the difference in the plants themselves immediately, very, very quickly, depending what crop you're growing and how quick of a crop it is. Soil changes are a little bit slower, but that's natural because what you're looking at. We've seen some phenomenal changes in the years.
That's very true about the how fast is it going to change the soil versus how fast is it going to benefit a plant. I had a farmer call me just a few weeks ago, probably 2 weeks ago, from northern Utah, and he told me that about 5 or 6 years ago he bought 2 semi-loads of TerraPro to put on his center pivots up there on his farm. And he said to me, he says, Michael, he goes, when I bought those 2 semi-loads, he didn't buy them from me. He bought them from an outside dealer. And so I was never aware of him. This first time I ever had a chance to talk to him. And he said to me, he goes, Michael, when I bought those 2 semi-loads, I had buyer's, what do they call that? Buyer's remorse. He said, man, I said, I could kick myself in the rear. I just bought a whole bunch of snake oil. And he says, but he went ahead and put it down on his fields anyway. And he irrigates with center pivots, and it's not level. And so he said he had some spots that are high and dry, and the crop would not grow very well there because the soils are too dry. And he had other spots that were low and wet, and the crop wouldn't grow there because it was too wet. Well, 5 years later, he's out there looking at his crop, and he realizes that the high and dry is no longer high and dry, and the low and wet is no longer low and wet. And the whole field looks wonderful. And his soil was full of worms, earthworms. He says, I've never seen earthworms anywhere on this farm before. And he realized that, his rapid judgment as to the TerraPro being snake oil was an incorrect judgment, that this had actually been working all along. And so he called me up and wanted to know how can he buy more. So it was great to hear from that guy. And that's not the first time I've heard that story, by the way.
Well, you've sampled our soil here at our place, and when we first started, we had no black soil in our beds. Right. In 3 to 5 years, we had 3 to 5 inches. And the last time you were out here, you put the shovel the whole way down in, and we had black soils where right outside the fence line, it's red clay sand. So there's been a dramatic difference in our soils here, but I've realized you got to have a little patience and just let nature do its work instead of out there, right, moving tons of manures and composts and mulches around. Just let nature do its work, and you instigate the whole process with the TerraPro.
Yeah, your soils had a percent organic matter before you cultivated, before using TerraPro. It had a percent organic matter that was negligible, and so the actual total carbon percentage was so low you really couldn't measure it. And because remember, organic matter, soil organic matter is not 100% carbon. It's only about 58% carbon. So if your soil level is less than 1% soil organic matter, then your carbon level is really, really small. So what I did on your site is when I came back at year 12, that's when I did that sharpshooter spade.
Yeah,
that was an 18-inch deep spade that we shoved all the way down, and you had rich carbon soil going down 18 inches deep.
Right.
And your percent organic matter was what? You remember?
No, I can't remember the number right now, Michael.
12%.
Yeah.
It was 12%.
12.
Was it 12? Yeah.
So if you take 12% of an acre of soil, 1 acre of soil, 1 foot deep, is 4.5 million pounds. So 12% of 4.5 million pounds will tell you how much total organic matter you have. That's a huge number, huge number. You're not going to be buying that much compost.
We
Right.
definitely went, like I used to, before I met Michael, I used to make about 10 ton of compost a year. And you're always trying to find materials, and it's difficult to find things that you're not bringing weed seed in or chemicals from something, from lawn clippings that people had, or it was always a real challenge. Whereas using the Soil Secret products is so much easier, and much easier on Joseph because he doesn't have to haul so much organic matter trying to bring it in. We just bring in mulch now, is mostly what we bring in, is just mulch.
Yeah,
But it's made it so much easier, and the results are so much better. We didn't get this increase in the carbon at all. It would just disappear when you're using compost. It just disappears and you wonder where everything went that you put in. Whereas you're using the TerraPro and the protein crumblies and mycorrhizae, it multiplies and grows the black. So
yeah,
it's pretty neat to see the results. And we work with lots of farmers, and so they're all using it now, and we're helping them grow as well.
I bought a dump trailer to haul manures and mulches and all that, that kind of thing. And after starting with the Soil Secrets TerraPro protocol, that dropped down 90%. I don't do it hardly at all anymore.
Much easier.
You just let nature do its work. And so I haven't hauled all that carbon in, that's for sure. Thank God.
yeah, you're getting. Yeah, that's a lot of work there, Joseph. Well,
Yeah.
anybody else have any questions before we sign off?
Michael, I have two.
Okay.
One is you didn't give us any contact information for Sterling Company.
We did, but you must have missed it at the beginning.
Okay.
But I will repeat it.
I don't know if I'm ready. I don't know if I'm ready to accept it right now
Okay.
because I'm on, on your screen. But okay, I'll get it from you. And the other one was, I guess I don't know the real question. The USDA is pushing cover crops for soil improvement.
Mhm.
How would you say that the TerraPro compares with those kinds of methods, crop rotation and cover crops, and to improve the soil?
They're very compatible with each other. I'm a strong advocate of cover crops and rotation, and so I think what the USDA is promoting there is right on it.
Okay.
I would say our best results came with the TerraPro, using cover crops and TerraPro. That combination together, we see the fastest results. Because that mycorrhizae has all that root to multiply on and to work with. You have that density of plants. So we see our best results when we use that combination of cover crops and Soil Secret products together.
Because you have a living root that the mycorrhizae can attach to and continue to grow for a longer period of time in any kind of soil application.
That's correct.
Gotcha.
Yeah. Well, thank all of you for your participation. We've lost a few, I think, in the last few minutes, but it was a pleasure being able to give this presentation to you. I thank you for your time, and hope that you learned something. And feel free to send me emails with questions that you think of later on. I'll be happy to answer them. And hope you all have a safe and Merry Christmas, and stay away from COVID and stay healthy. Take a lot of vitamin D, 10,000 international units of vitamin D, 50 milligrams of zinc, and lots of seed. And do that every day. Stay healthy, folks. Okay.
Yeah, I take hydroxychloroquine, and that's very effective as a preventative.
Excellent. Yeah. So let's boost that immune system, and drink lots of water. And also, there's even research to show that if you keep the humidity high in your room at night where you sleep, that's very beneficial. So humidify your bedrooms. Let's get through this. We'll survive.
Yeah.
Right.
Well, thank you very much.
All
Thank you,
right.
Michael.
Thank you.
Thank you.
Signing off.
You're sending this onward to us?
Yes, this will be, it's been recorded and we will post it on YouTube. And we'll send you an email with it.
Email that to me, and there's a reason why. You brought up something right now, and you know that's where my energy is killing the virus. And the virus is protein. So I have some ideas to utilize some of this
Mhm.
moving forward, as you
Right.
know me.
Yeah, Laura, we'll have, once we have it made into a YouTube video clip, then we can send the link to you.
Okay,
so
would you
Laura
do
has
that?
Laura has everybody's email address.
I'll
and
keep
stuff.
you abreast of what I'm doing.
Yeah.
Using nanotechnology to kill the virus. Okay,
Sounds good.
thank you.
All right. Thank you all.
Bye.
Bye-bye.
Bye. Bye-bye.